1.2, merge operation. Now we understand why we need to do this merge operation. Here, the idea actually pretty straightforward, so we can understand easily how to achieve balanced subarrays. Very easy. So here, I just use a simple diagram to show you the idea. The basic idea, whenever we merge two subarrays, or whenever we can split one big array into two smaller subarrays, because after we do the split, eventually we need to merge, right? So here, but at the beginning, we consider the split step. Okay, split original array into two subarrays. We make them of equal size, or as equal as possible, as even as possible. Here, suppose this is a given array. So when we start, we split right in the middle. So make two subarrays as even as possible. Because when we are given an array with odd number of elements, we cannot do even split, right? But we can do a split with two subarrays. The size difference is 1. That's the best, that's the most balanced way we can do. So that's the meaning here, as even as possible. Here, the diagram like this. Split right in the middle. Next time, two subarrays, when we do the split, still in the middle, right? And so on. Keep doing that, so you can see each subarray becomes smaller and smaller. And we have to stop splitting somewhere. So stop splitting when each file contains one element. Then we do not need to split one element, right? So after that, we do the merge. Merge two adjacent ordered subarrays. Suppose we can solve our problem number 12, then we apply it, we can get a merge step. All right, after that, at each round, we will do several rounds. The next round, merge another two bigger adjacent ordered subarrays. Keep doing that. So our subarray size becomes larger and larger, and finally, all the subarrays are merged into one big ordered array. So that's the basic idea. You can see, very straightforward, but it is different from all of the old ideas we used before. And we hope this method can help us avoid the poor worst case performance. Poor worst case performance. So that's our main target of this method. All right. Next, we need to study the main step, the merge step. Here, I just use diagrams to explain the merge step details. After you see my explanation using these diagrams, you can understand the merge step easily. It's pretty simple, straightforward. Not very complicated. So let's look. Suppose we have these two subarrays, both ordered. Now we start doing the merge. All right, we compare at the beginning two smallest element in these two subarrays. Yeah. We have the minimum element and the maximum element of the two candidates. Okay. Then our destination array. Yeah. Here. So we arrange locations for the destination array. So we put all the elements in place. That's the goal. Yeah. All right. After the first comparison, yeah, we have the min 0, max 0, smaller one, and a larger one. Right? And you can see the smaller one should be in the first element in the destination array. Or we can say the smaller one can be placed in place. So after one comparison, we put the smallest element in place. All right. Next, the next round. Okay. Yeah. So here we assume this. Suppose B0 is the max 0 one. That's case 1. And there is case 2. A0 could be the max 0 one, but it's similar. So we only discuss this case 1 here. Okay. Now B0 is the max 0. Next comparison, we compare A1 with B0. Okay. The smaller one we call min 1, and we can put that in place, min 1 in place. Okay. The larger one, then we will look at the element in the other subarray, the candidate from the other subarray, the smallest element that is not in place in the other subarray, we will use that to do the next comparison. For each comparison, the smaller one will be placed in place in the destination array. So in this way, you can see we keep doing in this way, and eventually we can get all the elements in place, right? All the elements in place. But the last one, we do not need to do comparison. We can put it in place, right? So here you can see for every new min added, we may need one comparison except the last one. The last one, we don't need any comparison. We just put it in place. Okay. So now you can see we look at the worst case. In this situation, we look at the worst case. Yeah. The worst case, yeah. So this corresponds to the worst case. Yeah. We need to do comparisons all the way to the end except the last element. Okay? So the number of comparisons we will do, yeah. So that is, for the worst case, the total number of elements in two subarrays minus 1, minus the last one. We don't need to do any comparison. Yeah, minus 1. Yeah. All right, so that's the answer, right? Yeah. But next, we want to consider the general merge step. The general means the two subarrays may not have the same size. Yeah. The first one has n number of elements. The second one has n number of elements. When they have different sizes, then we can use the similar way to get the worst case efficiency. Yeah. So for the worst case, here you can see we use the total number of elements except the last one, minus the last one. Yeah. That is m plus m minus 1. Yeah. Similar analysis. Yeah. All right. Next, best case, right? We want to consider the best case for the general merge step. Now, that's also pretty easy. Yeah. But for the best case, remember, we want to do the minimum number of comparisons, right? We try to get the best case in which we just do the minimum number of comparisons. How to get that? Yeah. Here, we use this strategy. Yeah. The strategy. Yeah. Because when every comparison, we select one element from the first subarray, another element from second subarray, right? Yeah. Make this observation. If we exhaust one of the subarrays, then the whole merge step is done, right? If we can exhaust one of the subarrays, then we do not need to make any other comparisons, right? So the strategy is like this. Try to exhaust one of the two arrays as early as possible. How can we get this? Try to exhaust one of the two arrays as early as possible. How can you do that? How can you get this best case scenario? That's easy. The smallest element in one subarray is greater than the largest element in the other subarray. How about that? The smallest element in one subarray can beat all the other elements in the other subarray. When that happens, we can exhaust one of the subarrays as early as possible. Okay? But we have two ways to exhaust two subarrays, right? The first way, exhaust the first subarray. Second way, exhaust the second subarray, right? Two ways. Which one is better? We exhaust the smaller subarray. That's the best case we can have. Okay? Exhaust the shortest subarray, the shorter one. We have two, so we try to exhaust the shorter one. Now we can get our best case efficiency. Exhaust the shorter one. Yeah. So we just need to do the comparisons for all the elements in that shorter subarray. Right? Yeah. So the best case efficiency, the minimum of two size numbers, m and n. Minimum of m and n. Best case. Okay? So the worst case, m plus n minus 1. The best case, the minimum of m and n. Now, remember these two numbers. Yeah. Because later I will give you some interesting questions based on these two numbers. These two formulas. All right, so we finish part F.2. Then the last part, F.3. The last video of the merge sort.